In July 2024, under the bright assembly lights of a factory in Crewe, 45 craftsmen and women stopped working. They had just finished bolting together the final 6.0-liter twin-turbo W12 engine block. After 6.5 hours of hand-building, the tools were put down, and a production line that had run for 2 decades finally went quiet. This was not a failure of demand. Over 20 years, this factory had built more than 100,000 of these 12-cylinder power units, single-handedly anchoring a modern luxury empire. The paradox of the Bentley W12 is that it did not die because buyers walked away. It died because global emissions targets, electrification mandates, and tightening legislation simply no longer permitted it to exist. It was engineered to effortlessly conquer continents, but it could not outrun the rulebook. But the real story of the Bentley W12 is not only the story of a discontinued assembly line. It is the story of how an impossible German layout was transformed into the ultimate British sound of luxury, and what happened when that sound became illegal to keep. Every week, we tell the stories of British engines, factories, machines, and industrial names that once taught the country what power sounded like, and what happened when the market moved on. Subscribe if that history matters to you. The story begins not with nostalgia, but with a specific place, in Crewe in 2003. To understand why the W12 was necessary, you have to look at the reality of the Crewe factory in the late 1990s. The historic Cheshire site was a monument to old British engineering, but it was trapped in the past. Bentley was tethered to Rolls-Royce, surviving by selling heavy luxury saloons that were essentially identical, save for the badge and the radiator grille. The heart of this operation was the venerable 6.34-liter V8, an 8-cylinder engine with its cylinders arranged in 2 banks in a V-shape. It was an overhead valve design that traced its lineage all the way back to 1959. It was torquey and charismatic, but entirely outmatched by the modern multi-valve V12 engines emerging from European competitors. In the world of elite luxury, Britain was falling behind. The old engines were hand-built, but they were heavy, thirsty, and incapable of meeting the looming future of global emissions and performance expectations. The dealers knew it, the mechanics knew it, and the factory floor knew it. Britain simply lacked a modern, high-volume luxury grand touring power plant. Then came the corporate shock of 1998. The British luxury car industry was fractured in a fierce boardroom battle between Volkswagen Group and BMW. When the dust settled, BMW took the rights to the Rolls-Royce name, while Volkswagen Group acquired the Bentley marque in the historic Crewe factory. For the workers in Cheshire, it was a moment of profound uncertainty. Bentley was suddenly separated from its sister brand for the first time in nearly 70 years. To survive as a standalone marque under new ownership, Bentley could not just offer a tuned version of a dated V8. It needed to reinvent the British Grand Tour. It needed a completely new car, and crucially, it needed an engine that did not yet exist in the British catalog. A traditional V12, a long engine with 12 cylinders arranged in 2 banks, was deemed physically too long to allow for the cabin space and all-wheel drive system required for a modern, all-weather luxury car. Crewe needed a breakthrough, but the factory did not have the capital to design one from a blank sheet of paper. The solution began not in a Midlands machine shop, but in Germany, driven by the sheer will of Volkswagen Group chairman Ferdinand Piëch. Piëch had a vision for an ultra-compact 12-cylinder engine, a design he famously first sketched on the back of an envelope while traveling on a high-speed train in 1997. His idea relied on the architecture of the VR6, a highly compact 6-cylinder engine with a very narrow angle between the cylinders, allowing them to share a single-cylinder head. By mating 2 of these VR-style blocks onto a common crankshaft, engineers created the W configuration. It was essentially 4 banks of 3 cylinders, staggered and intertwined. The resulting W12 was remarkably short, barely longer than a conventional V8, yet it possessed the sheer cylinder count required for absolute luxury prestige. When the final design was secured for Bentley, it was established as a 6.0-liter unit. Displacement, the total volume swept by the pistons inside the cylinders, is the traditional metric for luxury power, and 6.0 liters placed it firmly at the top of the automotive hierarchy. But Piëch and the engineers knew that a naturally aspirated heavy car would feel sluggish off the line. To give it the effortless surge expected of a British Grand Tour, they added two turbochargers. A turbocharger, a device driven by exhaust gases that forces more air into the engine, allows the machine to burn more fuel and create massive power without needing to rev highly. This was the critical decision that would align a German blueprint with British motoring identity. Bringing the W12 to Britain required a total transformation of the Crewe facility. In the early 2000s, the factory floor was fundamentally overhauled. The historic sheds that had spent half a century casting and machining old pushrod V8s were modernized to receive the W12. The bare engine blocks and internal components would be cast and machined by the parent company in Salzgitter, Germany, but the final assembly, the precise marriage of parts, the testing, and the installation would belong entirely to the workforce in Cheshire. This was a fragile cultural moment. British mechanics and assembly workers were suddenly faced with a deeply complex, tightly packaged machine that required entirely new assembly protocols and precise thermal management. Yet as the pre-production engines began to run on the test beds in Crewe, the factory realized what it had been given. Muffled by its twin turbochargers and heavy exhaust tuning, the W12 did not scream like an Italian exotic or whine like a pure racing engine. It produced a deep industrial bass. It sounded like a fast locomotive. It sounded exactly like a Bentley. In 2003, the W12 made its official British entry under the bonnet of the all-new Continental GT. The impact on the luxury market was violent and immediate. The Continental GT was not a traditional, chauffeur-driven saloon. It was a heavyweight, all-wheel drive coupe designed to cross continents at immense speed. At its heart, the W12 produced a confirmed 560 brake horsepower and a tidal wave of torque, the twisting force that gives an engine its feeling of pulling strength and acceleration. The numbers were staggering. It could propel a car weighing nearly 2.5 tons past 190 miles per hour, doing so with an eerie, unrelenting smoothness. In a single stroke, Bentley had moved from building charming, outdated aristocrats to producing one of the fastest four-seat cars in the world. The dealer network, which had grown accustomed to selling low volumes to a traditional, aging clientele, suddenly found itself taking orders from entirely new demographics. It proved that a modern British luxury car could command global volume. The marque had survived the corporate fracture of 1998, and the factory town of Crewe had secured its industrial future. But surviving was only the first step. The engine had reached the factory floor, but to understand how it saved the marque, Britain had to understand what a W12 actually was. To understand how the W12 conquered the British luxury market, you have to look at what physically arrived on the shop floor at Crewe. A traditional 12-cylinder engine is long. If you place 12 cylinders in a straight line, or even arrange them in a conventional V12 layout, a 12-cylinder engine with cylinders arranged in two banks in a V shape, the block takes up massive real estate under the bonnet. This sheer length pushes the transmission backward, invading cabin space, and makes it incredibly difficult to package the differential needed for all-wheel drive. A drivetrain setup that sends power to all four wheels simultaneously, transforming how a heavy car grips a wet British motorway. Volkswagen Group's solution was the W configuration. Instead of two long banks of 6 cylinders, the W12 effectively squeezed 4 banks of 3 cylinders onto a single, highly complex crankshaft, the rotating shaft that turns piston motion into rotational power. The result was a block, the main engine structure that holds the cylinders and major internal parts. That was astonishingly compact. It was 24% shorter than a conventional V12. This physical brevity was the breakthrough. It allowed Bentley to push the heavy engine entirely ahead of the front axle, freeing up space to route power to the front wheels while maintaining a spacious, leather-lined cabin. But a German blueprint is not a British luxury engine until it is built, tuned, and tested by people who understand what a grand tourer is supposed to feel like. At the Crewe factory, transforming bare metal into a Bentley power unit was not an automated robotic process. It was an intensely human one. Every single W12 was hand-built by a dedicated team of 45 craftsmen and women. The assembly process took exactly 6.5 hours per engine. The block arrived bare, and over the course of the shift, it was populated with exactly 2,600 individual parts. The cylinder head, the upper part of the engine that helps seal the cylinders and contains valves and combustion passages, was carefully bolted down by workers who, just a few years earlier, had spent their days building old pushrod V8s. At the end of the line, every completed engine was subjected to a rigorous cold test. It was spun by an electric motor to check for oil pressure, timing anomalies, and leaks before it was ever allowed to ignite fuel. A select number were pulled off the line each week for a full hot test, run to their absolute limits in a dyno cell to ensure that the horsepower figures were not just corporate promises, but physical fact. The transition to this modern powerhouse was not easy. The W12 was a packaging nightmare. Fitting twin turbochargers, complex exhaust manifolds, and immense cooling plumbing into such a tight engine bay meant that thermal management was a constant engineering war. The engine produced a staggering amount of heat. If the cooling system, the network of radiators, pumps, and fluid passages designed to keep the machine from destroying itself, failed to dissipate that energy, the car would simply cook itself in slow London traffic. But the engineers in Cheshire solved it, insulating and ducting the engine bay so thoroughly that the driver would never feel the mechanical violence happening just inches beyond the dashboard. When the Continental GT finally hit traditional Bentley dealerships in late 2003, it created a shockwave. For decades, traditional British luxury cars had been built primarily for the person sitting in the back seat. The chauffeur dealt with the driving, the owner dealt with the silence. But the W12 changed the entire geometry of British wealth. It was designed for the owner to drive. If a buyer walked into a showroom in Mayfair or a dealership in the home counties, they were no longer looking at a charming, slightly archaic saloon that struggled to find traction in the rain. They were looking at an all-weather weapon. The all-wheel drive system, combined with the immense weight of the engine over the front wheels, meant the Continental GT could deploy its power on a wet, freezing Tuesday morning in the Yorkshire Dales just as easily as it could on a dry summer motorway. Competitors were suddenly caught off guard. Aston Martin offered beautiful, naturally aspirated V12s that sounded like pure racing engines but lacked the sheer, effortless, low-end pulling power of the Bentley. Mercedes-Benz offered powerful V12s, but they lacked the bespoke, hand-built British interior and the specific cultural weight of the Wing B badge. The W12 did not require the driver to chase the red line, the maximum engine speed permitted before mechanical failure. Instead, the twin turbochargers provided a tidal wave of thrust from almost idle. The car did not accelerate so much as it gathered momentum like a fast-moving avalanche. This mechanical character redefined what British Grand Touring meant for the 21st century. It was not about frantic gear changes or roaring exhaust notes. It was about absolute, unrelenting authority. The W12 was quiet when cruising, emitting only a deep, industrial hum. But when the throttle was pinned, it produced a heavy, locomotive-like rush of air and exhaust. In the factory, the mood shifted from survival to immense pride. The workers at Crewe were no longer just keeping a legacy brand on life support. They were building the heart of the most desirable luxury car in the world. The line was running at capacity. The old engine sheds were alive with a new kind of precision. The W12 had bridged the gap between modern German corporate engineering and traditional British craftsmanship, proving that the two could not just coexist, but dominate. The workshop understood the engineering. The market was about to discover what that engineering felt like at speed. The success of the Continental GT was not merely a brief spike in sales. It was a total recalibration of the British luxury market. By 2005, the sheer demand for the W12 engine forced the Crewe factory into a rhythm it had not seen in decades. The original two-door coupe had proved the concept, but to sustain a modern automotive empire, a single model was never going to be enough. Bentley introduced the Continental Flying Spur, a massive four-door saloon that took the exact same 6.0-liter twin-turbo architecture and stretched it over a longer wheelbase. Suddenly, the British executive class had a car that weighed nearly 2.5 tons, but could comfortably cross the 200-mile-per-hour threshold. In a Britain where an engine could decide whether an aircraft lifted from a grass airfield, a lorry made its delivery, a motorcycle carried a rider through the night, a bus left the depot, a racing car survived the next lap, or a luxury car kept its silence at speed, Power was not an abstraction. It was metal, fuel, labor, heat, sound, repair, risk, and trust. For the men and women bolting cylinder heads onto engine blocks in Cheshire, the W12 was the ultimate validation of their craft. Before the W12, traditional British luxury marques had survived on exclusivity, which was often a polite industry word for low production volumes and fragile economics. But by the late 2000s, the engine assembly hall at Crewe was operating on a scale that fundamentally altered the town's industrial identity. The bare castings still arrived from the Volkswagen Group foundry in Salzgitter, Germany, but the soul of the engine was forged in England. The 45 specialists on the W12 line were assembling engines at a relentless pace, yet the 6.5-hour build time per unit remained sacred. Every single engine still required the precise fitting of 2,600 individual components. Out in the service network, the W12 was changing the culture of British luxury maintenance. Historic dealerships like Jack Barclay in London's Mayfair had to adapt their workshops. The mechanics, technicians who were historically accustomed to the relaxed, low-revving pushrod V8s, were now servicing densely packaged, high-temperature power plants that relied heavily on advanced software and complex cooling networks. The engine bay was so tightly packed that simple jobs often required removing the entire front subframe. Yet despite the sheer heat and pressure generated by the twin turbochargers, the core mechanical block proved remarkably durable. It did not suffer from the fragile temperaments that historically plagued Italian exotics or older British sports cars. The engine's character became its greatest moat against competitors. A conventional V12, like those being built by BMW for the newly relocated Rolls-Royce plant in Goodwood, was designed for absolute imperceptible smoothness. An engine that felt as though it was not running at all. The Bentley W12, however, was tuned to remind the driver that a massive mechanical process was occurring just ahead of the bulkhead. When the throttle was opened, it did not shriek. It produced a deep, resonant industrial rumble. It was the sound of air being violently compressed, of heavy internal components moving with relentless momentum. As the decade progressed, the engineering team at Crewe continued to push the boundaries of what the W configuration could handle. They introduced the speed models, tweaking the engine mapping, the software instructions that tell the fuel injection and turbochargers how to behave. To extract over 600 brake horsepower, the torque figures climbed higher, transforming the driving experience into something closer to piloting a commercial jet on takeoff. The W12 had found its believers, and the factory was running at the absolute peak of its historic power. The badge meant speed, and the engine delivered it without hesitation. The block was ready, the network was secure, and the luxury was undisputed. But a single engine family cannot conquer the world on the back of traditional luxury saloons alone. The market was about to shift entirely, demanding a type of vehicle that British Grand Touring had never imagined, and the W12 was about to be asked to move a mountain. That mountain arrived in 2015, and it was called the Bentley. The global luxury market was shifting rapidly away from traditional low-slung Grand Tours and towards massive, high-riding luxury SUVs. Bentley needed a vehicle that could carry 5 people in absolute silence, cross a muddy Scottish estate without hesitation, and still accelerate down a German autobahn faster than a dedicated sports car. To achieve this, the new car weighed nearly 2.5 tons. There was only one power unit in the British arsenal capable of moving that much mass with the necessary aristocratic ease. The engineering team at Crewe took the W12 and heavily re-engineered it for this new dual-purpose life. The engine had to be modified to ensure it would not suffer oil starvation, a catastrophic loss of lubrication that destroys internal components when tilted at extreme angles on off-road gradients. They also added cylinder deactivation, a software-controlled system that shuts off fuel and valves to half the cylinders under light cruising loads in a desperate attempt to improve fuel economy. But when the driver demanded power, all 12 cylinders fired instantly. In the Bentley, the W12 was eventually tuned to produce a colossal 900 Newton-meters of torque. This was a staggering number. In a British service bay or a specialist garage, mechanics marveled at a machine that produced the twisting force of a commercial lorry, yet was refined enough that a coin could be balanced on the intake manifold while it idled. It made the Bentayga the fastest SUV in the world upon its launch, proving that the strange, compact layout Ferdinand Piëch had sketched on an envelope nearly 2 decades earlier was infinitely adaptable. By the late 2010s, the engine assembly line at Crewe was a scene of unprecedented British manufacturing triumph. To keep up with global demand, the factory had to maintain production for the Continental GT, the Flying Spur, and the Bentayga simultaneously. The assembly hall became a highly choreographed ballet of heavy lifting, precision torque wrenching, and relentless testing. This was no longer a boutique operation building a handful of engines a week. In a modern industrial Britain that had seen so many historic engine lines sold off, outsourced, or quietly shut down, the W12 room at Crewe stood as a brilliantly lit exception. The emotional peak of this era arrived when the factory celebrated the production of the 100,000th W12 engine. In a historic county built around railway engineering and aircraft engines, the workers paused to sign the final engine block of that milestone batch. The original 45 specialists had trained a new generation of technicians. They had taken a complex foreign design block of aluminium and turned it into the definitive sound of modern British luxury. The winged B badge on the engine cover was not just a branding exercise, it was a physical promise that the power underneath had been assembled, checked, and signed off by human hands in Cheshire. The W12 was everywhere. It was in the garages of London, the driveways of the home counties, and the vast export markets that kept the Crewe factory working day and night. It had dominated the modern era of the internal combustion engine, an engine that burns fuel inside its cylinders to create power, with absolute authority. The W12 had conquered the luxury market, but the sheer scale of its combustion was about to become a problem the factory could no longer tune its way out of. The first crack in the W12 empire did not come from a catastrophic mechanical failure, a collapse in luxury demand, or a sudden loss of factory skill. It came in 2017, quietly, from European regulatory laboratories with the introduction of the Worldwide Harmonized Light Vehicle Test Procedure, commonly known as WLTP. For decades, type approval, the strict regulatory process that dictates whether a vehicle is legally allowed to be sold, registered, and driven on public roads, had been a hurdle that Bentley could overcome with clever engine mapping and deep corporate pockets. But WLTP was different. It was a far more rigorous, real-world measurement of fuel economy and exhaust emissions. And it was designed specifically to hunt down large-capacity, high-consumption engines. The W12 was an engineering marvel, but it was still a 6.0-liter internal combustion engine with 12 individual cylinders firing in rapid succession. That meant immense thermal mass and a staggering volume of exhaust gas to process. To meet modern regulations, the engine relied heavily on its emission system, the network of sensors and catalytic converters designed to reduce pollutants from engine exhaust. A catalytic converter, an exhaust device that uses rare metals to chemically convert harmful gases into less harmful emissions, only works efficiently when it is hot. Because the W12 was so physically large and dense, it took critical seconds longer to bring its catalysts up to operating temperature during a cold start. Under the new rules, those seconds produced a spike in emissions that the factory could no longer hide. In the testing cells at Crewe, the engineering teams found themselves fighting a war against physics. They were spending disproportionate amounts of research and development capital not to make the engine faster or smoother, but simply to keep it legal. The market force driving this was not consumer preference. It was force 3, regulation, emissions, noise, and type approval. In a British regulatory landscape that was increasingly punishing large fleet emissions with massive financial penalties, the sheer scale of the W12's combustion was becoming a corporate liability. This regulatory pressure triggered a fatal shift within Bentley's own showrooms. By 2018, to hedge against the tightening emissions rules, the company introduced a new 4.0-liter twin-turbo V8 engine, sourced from the wider Volkswagen Group parts bin, into the Continental GT and Bentayga. This V8 produced 542 brake horsepower, barely a noticeable drop from the standard W12 of the era, but it was significantly lighter. Suddenly, in a dealership in Mayfair or a showroom in Cheshire, the sales calculation changed. The V8 made the heavy Grand Tourer feel more agile on a twisting British B-road. It was cheaper to buy, cheaper to tax, and vastly easier for the factory to certify. The W12 still ran beautifully, but it was slowly being boxed into a corner. It became the engine for absolute traditionalists, the buyers who demanded 12 cylinders simply for the prestige of the badge, rather than the mechanical necessity of the power. Out in the service network, specialist garages began to see the shift. When independent mechanics plugged their diagnostic laptops into the newer V8s, they saw a highly efficient, modern power unit. When they worked on the W12, they saw an aging, impossibly complex labyrinth of plumbing, heat shielding, and software patches desperately trying to keep a 1990s architecture compliant with 2020's law. The decline was not a sudden cliff edge, but a slow, calculated retreat. Bentley began quietly dropping the W12 option from certain regional markets where local emissions taxes made it utterly unsellable. The engine that had built the modern Crewe factory was gradually being relegated to special editions, flagship speed models, and low-volume coach-built projects. It was a classic symptom of an industrial empire in retreat. The product was pushed upmarket to justify the escalating cost of its survival. Behind closed doors, the corporate reality was even harsher. The automotive industry was already preparing for the looming Euro 7 emission standards, a set of rules so strict that they practically mandated electrification. The shift from fuel-burning mechanical power toward electric motors, batteries, or hybrid systems. To re-engineer the W12 to meet these future standards would have required hundreds of millions of pounds in development, a completely new cylinder head design, and hybrid integration that the compact W configuration simply did not have the physical space to accommodate. The iron was still strong. The workforce in Cheshire was still building the engine with exactly the same pride, signing the blocks under the bright assembly lights and sending them out to cross continents in absolute silence. But the legislation surrounding the engine had tightened into a noose. Britain did not stop needing luxury power, but the legal structure of the world had decided it stopped needing that specific kind of power. The block was still a masterpiece of British assembly, but the parent company was already drafting the document that would outlaw it forever. In November 2020, the document that would finally end the reign of the W12 was made public. Bentley announced its Beyond 100 corporate strategy, a sweeping manifesto that outlined the complete reinvention of the historic brand. The terms were uncompromising. By 2026, every vehicle leaving the Crewe factory would be either a plug-in hybrid, a powertrain combining a conventional combustion engine with a high-voltage battery and an electric motor that can be charged from the grid, or fully electric. By 2030, Bentley pledged to build electric vehicles exclusively. The internal combustion engine, the very mechanism that had saved the company in 2003, had been given a strict, unchangeable expiry date. The market force at work was no longer just emissions compliance. It was Force 6, electrification, hybrids, batteries, and software displacement. The automotive landscape was pivoting away from mechanical complexity and toward chemical energy and software management. For the dealership network, this meant a radical shift in how British luxury was sold. Buyers walking into a showroom were increasingly presented with the new V6 plug-in hybrid models. The hybrid system was highly logical. It allowed the heavy Grand Tourer to slip through zero-emission zones in central London in absolute battery-powered silence, avoiding the crippling congestion and emissions charges that now targeted large displacement petrol engines. The V6 hybrid was efficient, it was fast, and it easily passed the most stringent type approval tests. But out in the service bays and independent garages, mechanics understood what was being lost. The hybrid system was a triumph of code and battery chemistry, not cast aluminum and mechanical rhythm. It did not require a dedicated team of 45 craftsmen working for 6.5 hours to carefully torque down 2,600 individual components. The sheer physical presence of a 12-cylinder block, a machine that dominated the engine bay and dictated the entire character of the car, was being replaced by a highly competent but ultimately generic corporate powertrain. As the Beyond 100 deadline loomed, the atmosphere in the engine assembly hall at Crewe began to change. The company confirmed that production of the W12 would formally cease in the summer of 2024. But before the tooling was packed away and the workers were retrained for high-voltage electrical assembly, the engineering team in Cheshire was granted permission for one final, unrestrained calibration of the engine they had spent 2 decades perfecting. They channeled this final effort into a highly exclusive, coach-built Grand Tourer known as the Bentley W12. The engineers knew this was their last chance to prove what the W configuration was truly capable of before it was outlawed. They heavily revised the intake system, upgraded the turbochargers, and entirely redesigned the intercoolers. Heat exchangers used to cool the compressed air from the turbos before it enters the engine, allowing for a denser, more explosive fuel mixture. The numbers they achieved were a violent farewell to the combustion era. The final iteration of the W12 produced a verified 750 metric horsepower, or about 740 brake horsepower, and an earth-moving 1,000 newton-meters of torque. It was the most powerful internal combustion engine Bentley had ever created. When the W12 was tested, it did not just accelerate, it brutalized the air in front of it, propelled by a mechanical force that no battery-powered motor could ever truly replicate in sound or vibration. It was a glorious display of British engineering defiance, but it was also a tombstone. By the time the spring of 2024 arrived, the W12 line at Crewe was operating on borrowed time. The global supply chain that fed the factory was already winding down. The foundries in Germany were casting their final blocks. The parts bins in Cheshire were slowly emptying, and they would not be restocked. Dealerships took their final allocations, warning loyal customers that this was the absolute last opportunity to order a 12-cylinder British Grand Tourer from the factory. Then came July 2024. Under the bright lights of the assembly hall, the remaining members of the W12 build team gathered around the final engine blocks. There was no great industrial strike, no bankruptcy, and no sudden collapse in consumer demand. The engines were still highly profitable, and buyers still wanted them, but the world outside the factory walls had simply made them legal to sustain. The engineers signed the final aluminum casings, securing a 20-year legacy that had produced more than 100,000 engines and saved one of Britain's most famous marques. The engine still ran. The line stopped. The tools were put down. The factory was gone. But out in the world, the metal it left behind was just beginning its second life. The immediate aftermath of the shutdown at the Crewe factory was a quiet, highly managed industrial transition. The 45 craftsmen and women who had spent 2 decades bolting together the W12 did not lose their livelihoods, but they lost their machine. They were reassigned and sent to retrain on high-voltage electrical architecture, battery management systems, and the assembly of plug-in hybrid drivetrains. The historic engine hall in Cheshire, which had vibrated with the deep bass of 12-cylinder cold tests for 20 years, is being systematically stripped of its heavy engine stands and oil-stained testing rigs. It is being retrofitted into a sterile environment suited for the new electric vehicle platforms. The brand survived, the marque remains highly profitable, and Bentley will continue to sell luxury cars. But the physical, mechanical rhythm of the factory floor has changed forever. But out on the British roads, the W12 has entered its second act. It is passing from the pristine showrooms of Mayfair into the hands of preservationists, specialist mechanics, and marque enthusiasts. In independent garages across the home counties, the Midlands, and the North, the W12 is no longer viewed merely as a depreciating corporate product. It is increasingly treated as a peak historical artifact. Mechanics who once cursed the tightly packed engine bays and the labyrinthine cooling systems are now carefully overhauling these complex power plants. They are stockpiling genuine parts, sensors, and turbochargers, while the supply chain still occasionally provides them. This is not nostalgia. A Bentley W12 sitting on an engine stand in a specialist workshop is a physical argument about a specific era of British industrial history. It proves that there was a window in the early 21st century when the absolute pinnacle of grand touring was still defined by combustion, heat, and moving metal, rather than lines of software code, touchscreen interfaces, and battery chemistry. It stands as a monument to a time when solving an engineering problem meant casting a highly complex block of aluminum and managing explosive thermal energy, rather than writing an algorithm to simulate a driving experience. The replacement culture of the modern automotive market has made the early Continental GTs highly accessible. meaning these massive engines are occasionally finding their way into the hands of daring private restorers. On internet forums and in the dusty pages of Marque Club newsletters, a new generation of owners is learning how to maintain the twin turbochargers and the intricate vacuum lines. Old service manuals, soon to be stained with oil, are being passed around enthusiast networks. The service network has decentralized, moving away from the glass-fronted main dealers and into the fiercely knowledgeable independent British sheds, where the true long-term survival of any engine is ultimately decided. There is a deep irony in the engine's afterlife. The W configuration, a radical idea that Ferdinand Piëch originally sketched on a train envelope to package a six-cylinder engine into a small front-wheel drive German hatchback, ended up becoming the ultimate symbol of heavy British grand touring. It was an immigrant design that the workforce at Crewe adopted, refined, and built so masterfully that it became entirely indistinguishable from the heritage of the Wing B badge. It was a German blueprint that was taught how to speak with a British accent. The Bentley W12 was born out of a desperate need to save a historic British marque from irrelevance in 1998, and it succeeded so completely that it outlived the very era that required it. Britain did not stop needing power. It did not even stop needing luxury. It simply stopped needing that specific kind of power. The world moved towards efficiency, silence, and environmental compliance. The emissions regulations tightened, the fuel economy pressures mounted, and the looming electric era demanded an entirely different definition of what it meant to cross a continent in comfort. The sound of 12 cylinders firing in a staggered W formation will slowly fade from daily traffic, retreating to classic car shows at Goodwood, private collections, weekend runs across the Yorkshire Dales, and climate-controlled transport museums. But it will not disappear entirely. Somewhere in a British collector's garage, an early 6.0-liter W12 engine block sits perfectly preserved. The twin turbochargers are cold, the complex plumbing is completely still, and the aluminum casings gleam under the workshop lights. The signature of the person who built it in Crewe is still clearly visible on the metal, waiting for a deep, industrial sound that the new automotive world is no longer permitted to make. See you in the next video.